Good morning. It is 9 a.m. Central Standard Time, April the 21st, 2021. Welcome to the Dallas STEM Environmental Education Center for our virtual field trip on this cold April morning. We want to say a very special welcome to Bessie Coleman from Cedar Hill ISD, W.E. Griner from Dallas ISD, and Jose Joe May from Dallas ISD. Teachers, if you are watching and you have not registered, please do so. Go to www.tiny.cc/EEC register and sign up. And this is just for our attendance records only. This morning, we're going to do a program called the Solar System. During this virtual field trip, students will describe the physical properties, locations, and movements of the sun, planets, moon, meteor, asteroids, and comets. Understand that gravity is the force that governs the motion of our solar system and describe the history and future of space exploration. Ms. Ramirez will do a program called Sun, Planets, and Moon. Mr. Monroe will tell you about meteors, asteroids, and comets. Ms. Nash will get down about gravity, and space exploration will be performed by Ms. Janet Fuller. During this program, you cannot ask us verbal questions, but you can go to www.tiny.cc/EEC space question, space answer. Send in your questions and I'll do my best to answer them during the program. And if not, I will send the answers to your teacher and your teacher can go with them. Now I'm going to stop sharing my screen. And Ms. Ramirez is going to tell you about sun, planets, and the moon.
Hello, my name is Ms. Ramirez, and in this segment, we're going to do a brief overview of what's inside our solar system. So before we start our PowerPoint presentation, I just want to show you guys a couple of things. The first is this little paper model of our sun, and you can see the internal structure with the core, which we know that's where nuclear fusion takes place. We also see the bright corona. So just to put it into perspective, if our sun were the size of a doorway, then planet Earth would only be the size of a dime. So that is just how massive our sun is compared to everything else in our solar system. Now, later on, we're going to talk briefly about some of the other planets in our solar system. But before we get started, I just want to introduce you guys to an animal friend. This is Spike, and he is a bearded dragon lizard. And I brought him out today because he represents planet Earth. So as far as we know, Earth is the only planet that can sustain life. And that's why it's important for us to protect our planet and its natural resources. So Spike here is a bearded dragon, and they are native to Australia. So I'm going to go ahead and put him up, and we'll start our presentation on the solar system. So let me share my screen with you guys, and we'll go ahead and start. So I have two essential questions for you guys. Before I show you those essential questions, though, if you would like to make your own paper model of the sun, it's a free printable from Canon Creative Park, and the link is listed on the slide. But it's a really easy way for you guys to make your own paper model of the sun and its internal structures. So that's a neat little craft for you guys to do at home. Now, today we're learning about the solar system and what's in our solar system. So hopefully by the end of this presentation, you'll be able to answer these two questions. The first question is, where is our sun located? And the second question is, you should be able to name the terrestrial planets and the gas planets, and you should be able to describe at least two differences between a gas and a terrestrial planet. So keep those two questions in mind as we go through the presentation today. So we're going to go ahead and start off with our sun. So our solar system is composed of the sun and all the bodies that orbit the sun. And the model that we use nowadays is considered the heliocentric model, and that just means a sun-centered model. So we know that the sun is at the center of our solar system, and the sun is just a star. So the sun is massive, but it looks small because it's so far away. In fact, it's over 150 million kilometers away, or we can also say 93 million miles away. And we also refer to it as 1 astronomical unit. So since it's such a large number to represent in kilometers or miles. We typically just condense it down to 1 AU or 1 astronomical unit. We can also measure it in terms of distance in light years, and we know that it is 8 light minutes away. And our sun is just a star. In fact, it's the only star in our solar system, but there are many other stars in our galaxy. Now, our sun, if you take a look at this diagram over here, we can see that our sun and the solar system is located in the Orion spur or arm of the Milky Way galaxy. So our solar system is located again in the Milky Way galaxy. And it's about the entire Milky Way galaxy. You can see it's about 100,000 light years long, so it's massive. And our sun's location is about 28,000 light years from the center or the bulge of the Milky Way galaxy. And again, we know that the sun is just a hot ball of hydrogen and helium gases. And something interesting about the sun, it has what's known as differential rotation. So that means that different parts of the sun actually rotate at different times. So at the equator, it's rotating about 25 days. And then at the poles, it takes about 35 days to rotate at the poles. So just like planet Earth rotates, the sun also rotates as well. And then here's a quick infographic for you guys to see the internal structures and layers of the sun. And then in our next slide, it's just a brief overview of our planets. So we have 8 planets in total, and they are divided into terrestrial versus gas giants. So take a moment to compare and contrast those terrestrial planets with the gas giants and see if you can identify which planets are which. And when I was in school, the way that I remembered my planets in order was by a very simple sentence, and that is, my very excellent mother just sent us nachos. So if you can remember that sentence, then you know all of your planets in order. And we know that the first 4 planets closest to the sun are going to be our terrestrial planets. And then the last 4 planets are going to be our large gas giants. And you can feel free to take a moment to allow time for discussion on some comparisons between those planet types. But I'm going to go ahead and jump right into it. So the terrestrial planets, notice their location. They are closer to the sun, and they are more highly dense, and they're made of rock and metals. They also tend to rotate slower, and they have shorter revolutions. And that makes sense because these planets are closer to the sun, so it's going to take a less amount of time for them to complete their orbit or their revolution around the sun. We also know that our terrestrial planets have no rings, and they have fewer satellites. Now remember, a satellite is just another word for a moon. Now if we compare them to our gas giants, notice in our image here that our gas giants are going to be much bigger than our terrestrial or land planets. And these gas giants, as their name suggests, are composed mostly of very thick, massive atmospheres, but it suggested that they might have a solid core in the center of them. They also orbit further away from the sun, and because they're further away from the sun, their temperatures are much more colder. Also, these gas giants, they all have rings, although Saturn probably has the most noticeable and prettier rings, but again, all gas giants have rings. And then all the gas giants actually have moons. So there's a quick comparison between our terrestrial and our gas planets. And then in our next slide, we're going to talk about those moons. So we know planet Earth only has 1 moon, and a moon is simply a natural satellite. That means that it's going to be orbiting or going around a planetary body. And all gas giants have moons, and there's about more than 200 moons in our entire solar system. And some dwarf planets even have moons too. So now if we take a look at these pictures over here, our moon is really interesting because it has what's known as synchronous rotation. And it gets that because the amount of time it takes for it to complete 1 rotation and 1 revolution is actually the same. And because it has synchronous rotation, that is why we only see one side of the moon. So I thought that was pretty interesting. And then here you can see just a quick little infographic of the planets that have moons, and you can see how many they have. Now, when I was in school, Jupiter was known for having the most moons, but back in 2019, scientists actually discovered more moons of Saturn. So now Saturn has the designation of the planet with the most moons. So that's why it's important to always keep up with new science advancements, because they're always making new discoveries. So now you can take a look at how many moons each of these planets have. Now notice all of our gas planets have moons, but only 2 of our terrestrial planets have moons. And then I have a quick challenge for you guys. I would like for you to go to solarsystemscope.com and explore the virtual solar system, explore the sun, the planets, and the moons, and research their physical characteristics, their internal structure, and their locations and movement. So let me show you guys what that website looks like really quick. So here it is, solarsystem.com, and you can play around and visit each of these planetary bodies or even the sun. So for example, if we take a look at Venus, which happens to be my favorite planet, you can click on Venus, you can go visit it. It'll give you a quick little flyby of the planet. It'll also give you information on its structure, where it's located, and things like that. You can also look at the internal structure of these planets as well. So if we go to Earth really quick, it'll let you take a look at the inside and what it's composed of. So please take time to go visit this website and do your own research and exploration. So I'm going to go ahead and stop my screen share, and that's all I have for you guys for the solar system. We're going to give it back to Dr. Gorman to answer any questions.
Thank you so much, Mr. Maris, for that colorful and informational program. I am totally amazed now at the amount of information that is available just with the click of a mouse. It would have taken us a week to get the information you just gave us in a few short minutes, Sarah. Thank you again. And the question came in, what do the sun, planets, and moon all have in common? They are all part of our solar system. The planets travel around the sun, and the moon travels around the earth. And now Mr. Monroe is going to tell you about meteors, asteroids, and comets.
Good morning, students. My name is Mr. Monroe, and we're going to be looking into meteors, comets, and asteroids. You know, I grew up, well, let me say it like this. When I was very small, I grew up in a country town. And playing out in the yard after dark with my friends, we could see the night sky very, very good, simply because there was not any light distortion. And every once in a while, we would look into the sky and we would see a bright, twinkling light fall. And I used to hear my friends, and even I began to say this little saying. We sang it sometimes. Catch a falling star and put it in your pocket. Save it for a rainy day. Well, you know what that really meant? Is if we saw what appeared to be a falling star, we were supposed to make a wish on it. And that wish, supposedly, it would come true. Now, as I go through the presentation, I want you guys to kind of look at comets, meteors, and asteroids and figure out which one of those actually was the actual supposedly falling star falling in the night sky. So if you'll bear with me, we'll get started on the presentation. And I'm going to share my screen with you. Bear with me. Okay. We're going to start out by talking about comets, students. Now, when we talk about comets, that word comet comes from the Greek word hair. Yeah. Our ancestors thought comets were stars with what looked like flowing hair trailing behind. Dirty snowballs is what they actually appeared to be. Comets are loose collections of ice, dust, and small rocky particles whose orbits are usually very long, narrow in ellipses. The structure of a comet is this: the nucleus, which is the very center, the coma, which is the outer layer of the nucleus, and then we have what we call the hydrogen envelope, which is the outer layer, the very outer layer of the nucleus. And then we have the tail. A comet's head, the outer layer, the comet's head is outer layer is called a coma. It's made up of water vapor, CO2, and other gases. The solid inner core is the nucleus. It's made up of frozen gas and and dust. The comet's tail. As a comet approaches the sun and heats up, some of its gas and dust stream outward, forming a tail. Most comets have two tails. One made up of gas, ion tail. And then we have the other tail being made up of dust. The tails point away from the sun because of the flow or because of the solar winds. A comet's tail can be more than 100 million kilometers long. As you see here, the tail is facing away from the sun as it moves around in its orbit, okay? And you can see here in this image that the two tails do appear, the ion tail and the dust tail. The comet's orbit is elliptical around the sun. Origins of the comets, where do they come from? Most comets are found in two regions in the solar system, the Kuiper belt and the Oort cloud. The Kuiper belt, which is a donut-shaped region that extends beyond Pluto's orbit to about 100 times Earth distance from the sun. Wow, that's a long ways. The Oort cloud is a spherical region of comets that surrounds the solar system about more than 1,000 times the distance between Pluto and the sun. The other object that we see are asteroids. Now, asteroids are small and rocky space object. Most asteroids are found in the asteroid belt. The asteroid belt is located between the orbits of Mars and Jupiter. Right in this area here is the asteroid belt. Jupiter is way out here, and here's Mars, and this is the asteroid belt that you see all those particles in this area here. How many asteroids are there? Boy, that's an interesting question. There are about 40,000 known asteroids that are over 0.5 miles in diameter in the asteroid belt. About 3,000 asteroids have been cataloged. There are many smaller asteroids, 100,000. Asteroids are made of metals, silicate, iron, nickel, and carbon. The first one discovered, and the biggest, is named Sirius. It was discovered in 1801. Asteroids range in size from tiny pebbles to about 578 miles or 930 kilometers in diameter, and that was Sirius. Asteroids becoming moons. because of asteroids being pulled out of their solar orbit by gravitational pull of a planet, they would then orbit that planet instead of orbiting the sun. And at that point, astronomers theorized that they become moons. They also theorized that the two moons of Mars, Phobos, and Deimos are captured asteroids. Asteroid strikes. Scientists hypothesized that one or more large asteroids hit Earth 65 million years ago and caused the extinction of the dinosaurs. Scientists also hypothesized that the largest mass extinction, 250 million years ago, killing off 90% of all species, was caused by a large asteroid. Meteoroids. Meteoroid, a chunk of rock or dust in space. Meteoroids come from comets or asteroids. When a meteoroid enters the Earth's atmosphere, friction with the air creates heat and produces a streak of light that you can see in the sky. A meteor is a meteoroid that enters the Earth's atmosphere and burns up. As we see here, this is a remnant of a meteoroid. And we can see this crater that it has created. Okay. Over here is the image of a simple impact crater. Meteoroids that pass through the atmosphere and hit the Earth's surface are called meteorites. Classified by composition, stony iron or stony iron. Now, I'm going to stop sharing my screen here and going over the characteristics of all three of those objects. Which one do you think might have been what we were seeing in the sky and we had the illusion that it was a falling star? Of course, today we know that stars do not fall. If you guessed meteors, you were correct. Now, if you guys have any questions, I'm going to turn it over to Dr. Gorman, and maybe he can answer some of those questions for you. All right, Dr. Gorman.
Mr. Monroe, very interesting program. One thing that I would like to say, though, is that you and I share a lot of common qualities. And one of the things that we share is our inability to sing. So, Mr. Monroe, please keep teaching because you're a great teacher. And I can't say that much about your singing ability. Okay, where do meteors, asteroids, and comets come from? The question that was sent in. Our solar system's small bodies, asteroids, comets, and meteors, pack big surprises. Asteroids and comets and the meteors that sometimes come from them are leftovers from the formation of our solar system 4.6 billion years ago. And now Miss Nash is going to tell you about the great force of gravity.
Welcome to my classroom. I'm sitting here thanks to gravity. And thanks to gravity, everything is staying where I put it. Lucky us. And it's good to think about but they were just talking about the formation of the solar system, because that is also thanks to gravity. So we'll look at a few pictures and then talk a little bit about more things, including the apocryphal apple. So let me share my screen here and see what we can see in outer space. Okay, so our star and the solar system that surrounds it began in a star-forming nebula. Nebulas are clouds of dust and gas. And as we know, gravity pulls things together, holds things together. And in that cloud, things begin to clump together. If enough stuff clumps in one spot, it can create what we call a protostar. And then there's a whirling cloud around it. In that whirling cloud, things can also begin to clump together. And those things clumping together are the planets. And again, that Oort cloud and all the other stuff that's out there that did not actually clump together to form planets, is still held around our sun because of the force of gravity of the sun. Now, the force of gravity, of course, is proportional to the size of the object. Everything has gravity. Everything that has mass has gravity. But the amount of gravity depends on the mass. The force of gravity depends both on mass and how close you are to the object. So after everything began clumping together, we ended up with our solar system as we know it. So the first person to kind of codify gravity or think about it deeply was Sir Isaac Newton. And he had been at university and he had to go out to the country because they were having a big plague in the cities. Sound familiar? Anyway, so he had to go out in the country and he had a lot of time to think. Okay? And that's where he formulated his famous laws of motion and also the law of gravity. Okay? And it says that the force of gravity from the sun holds the solar system together. The larger an object mass, the greater its gravitational force. Now, the orbit of the planets or the moons around the planets is a combination of gravity versus inertia. So another law of Newton is that an object in motion will stay in motion. An object at rest will stay at rest. So the planets are in motion. They want to go straight, but the force of gravity pulls them toward the sun. So those two forces are in balance. And when those two forces are in balance, it creates the orbit. So it's gravity versus inertia, or the force of motion that wants to keep going, okay, that are in balance. And that's why we have the orbit. So on our planets, if we have moons, we also have the force of tides. So on planet Earth, because we have all that water around our planet, the force of the gravitational pull of the moon and the gravitational pull of the sun combine to create tides. And so the high tides are when the sun and the moon are in line, pulling in the same direction. So if you ever get to go down to the coast, you can see where the tide mark is. Twice a month there are high tides and twice a month there are low tides. And that's because the moon is orbiting our planet. Now, on other planets, they're also, let me go back to tides. So tides are actually just something I learned, that tides occur, of course, even if you don't have water or a tidal pull, okay? And they think that on some other planets, we have what we call tidal heating, okay? And so in planets are moved out water, tidal bulges. Okay, so on our planet, we have what we call a tidal bulge where water is being pulled out. Okay, but on planets without water, we can still have a bulge, a tidal bulge, but it's land. And in some cases, this bulge created by gravity is pulled back and forth, and it can create friction. And this just can cause what we call tidal heating. Io, one of Jupiter's moons, tidal heating has caused volcanic activity, they think. And this heating may also be responsible for volcanic activity on Saturn's moon Enceladus and liquid water underground on Jupiter's Europa. So I thought that was really interesting, that tidal force can actually cause heating, okay, through friction of the movement of the material of the planet. Another thing to think about is the fact that gravity, how much you weigh depends on gravity. So I was thinking about this with the Mars, the little helicopter that I had on Mars. And I was thinking that, oh dear, Mars doesn't have much atmosphere. How can they possibly fly something on Mars? Because there's not enough, the atmosphere is not thick enough to really hold things up. And then I thought to myself, self, but Mars does not have as much gravity as Earth. So the pull down is less also. So apparently they were able to fly because I saw it myself with my very own eyes. So it's a really interesting thing to think about. And you can go to various little websites and calculate your weight on all the different planets. Of course, on the bigger planets, you're going to weigh a lot less. Okay. And on the smaller ones, you'll weigh, on the smaller ones, you'll weigh less, and on the bigger ones, you'll weigh a lot more. Okay. So let's see. There we go. Okay, so gravity is important for us. It's important for planets. Gravitropism helps them grow their roots down. They know how they can feel that force of gravity, and their roots grow down. Okay, otherwise, they wouldn't be able to grow. And we can all, because it's Earth Day, we can all be thankful for gravity, holding our planet together, and also do our part to keep our planet in good shape. Okay. With the help of gravity, we can do a lot of things. So thank you. And if you have any questions, you can ask Dr. Gorman.
Thank you so much, Ms. Nash. And what force keeps the planets revolving around the sun? And I'm sure Ms. Nash covered that very thoroughly. And it is gravity. And I'm amazed at a force such as gravity. We can't even feel it, yet it keeps us firmly planted on the earth, and it keeps the planets revolving around the sun. That's a pretty powerful force. Thank you again, Ms. Nash. And now Ms. Fuller is going to tell us about something that's very close to me and to my heart, space exploration.
Good morning, boys and girls. My name is Mrs. Fuller, and this is a desktop cardboard model of the Orion spacecraft, which the NASA is going to use to help us go back to the moon and then eventually send people to Mars. Isn't this amazing? And I'm going to put this down. We're going to be talking for the next few minutes about the space exploration. So let me share my screen with you. And we'll get started. So, space exploration, humankind's drive to go beyond the Earth. Over on the left-hand side is an illustration from a book that was written in 1865 by Jules Verne called From Earth to the Moon. And it's about what we've been doing. And we were actually able to actualize it over 100 years later. And the idea it's a science fiction book, and the idea in it is to send this projectile, this big bullet looking thing, to the moon with 3 astronauts in it. They dug in the story, it's not real, it's a fiction book, it's science fiction, but they dug a 900-foot deep pit, and they filled it with explosives, and the explosive material was called Columbiad. Columbiad. Keep that word in your mind, Columbiad. And then if you'll look there in the middle, you see Flash Gordon's spaceship, and over on the right is the first artificial satellite set in orbit around the Earth, Sputnik. Now let's talk a little bit about our fascination with space. Just like Mr. Monroe talked about lying out in the yard at night in the country and looking up at the stars and wondering what was out there, people have wondered for a long time, how can we go to space? And these comics, very similar to Marvel's comics and DC comics that we watch now about X-Men and that sort of thing. These things were science fiction comics about guys that could go into space and have spaceships. And one was Flash Gordon and one was Buck Rogers, not Buck Owens. Okay, let's look at a couple of essential questions. What was the first manned space vehicle? There's a picture of it on the far right-hand side, Sputnik. No, excuse me, that wasn't manned. That was just a satellite. And what was the name of the Soviet space vehicle that the USA, that sent the USA into a space frenzy? That was Sputnik. But the guy who went in the first manned space vehicle was Yuri Gagarin. That's a picture of him in the middle, and that's the vehicle he rode. Look at that thing over on the far left-hand side. It's called Vostok 1, and looks kind of scary to me, but he came back, and he came back alive. So that was the first manned space vehicle. It was Soviet. That was the Soviet Socialist Republic, what we now call Russia, and was Russia before it was USSR too. And that's his picture in the middle. Now, over on the left now, you see Sputnik. It's about the size of a basketball, and it just sent the United States into a tizzy because we thought the Russians were ahead of us in the space race. We were already in a Cold War, post-World War II, and this set everybody upset because they thought that they were going to get ahead of us. So there's Gagarin's Vostok 1 again in the middle, and over on the right is the first space capsule that we used, and it was called Mercury, and held one guy. And this is what it looked like. It's the inside. It was very cramped. This is the ballistic capsule. This is Mercury 7. And it shows where all the little parts are, and I do mean the little parts. Some of the early astronauts disparaged this kind of vehicle and referred to it as spam in a can. The can was the ballistic capsule, and the spam was the human being, because they didn't really do a lot other than go up and go down, or go up and go around a couple of times. Then they came out with another kind called the Gemini. The Gemini project sent 2 astronauts into space, and this is a Gemini capsule right here, and they stuffed 2 people in there. And then we had the Apollo program, and it was Apollo 1 through 17. Not all of them went to the moon. Apollo 11 was the first one that actually went to the moon, and people got out and walked on the moon. That was Neil Armstrong and Buzz Aldrin, and then Collins, astronaut Collins, stayed on the device that was circling the moon so they could get back safely. All right, now you know, a minute ago I told you about Columbiad, that big explosive device that would throw the projectile up to the moon with Jules Verne's. Well, Apollo 11, its command module, the one that Collins stayed in, it was called Columbia, and it was named after the Columbiad in that science fiction book that Jules Verne wrote back in 1865. So I just assumed it had been named after America because the name Columbia and America are very closely related. It was actually named after that. And the lunar module for Apollo 11 was called the Eagle. And now there's Orion, the one that I showed you the model of earlier. This is the one, the next time we go to the moon, it's going to have 3 big missions. The first one's go to the moon without people. And then they're going to go to the moon with 4 astronauts. And then after, so it's the program itself is called Artemis. And then the module is called Orion. So Artemis 1 is going to be a test flight. Artemis 2 will be the next trip to the moon. It's actually going to go past the moon. And Artemis 3, Orion will take astronauts to the lunar South Pole. So test flight, past the moon, and then Artemis 3 will take the astronauts to the South Pole. And then once those are all successful, then the next thing would be to send it to Mars. So let me see if I can. So Mars and beyond. So Ms. Ramirez talked to you about the 4 rocky planets, the 4 terrestrial planets. There they are on the bottom: Mercury, Venus, Earth, and Mars. And you see Mars is significantly smaller than Earth. You can see the Mars rover above that. The picture on your right is the South Pole that they're going to be going to. And I'm going to show you something just a second. So let me go ahead and stop sharing my screen with you. This is what Ms. Nash was making reference to about this little drone helicopter. And this happened this past week, and it was so exciting. There is so much wonderful, wonderful exploration to be done, and you're the generation that will be doing it. So, well, we're very happy for you, and that's wonderful. So let me show you our last thing here. And here's a picture from NASA, and that little cardboard model came from them and came from this little booklet. And I hope you have a delightful day, and live long and prosper. Thank you so much. If you have any questions about space exploration, Dr. Gorman has a real interesting story about that.
Thank you so much. First question was, when did Neil Armstrong and Buzz Aldrin walk on the moon? And it was in 1969. And yes, I do have a story about that. The night that they walked on the moon, or the night that it was televised back to Earth, I was in the ready room of an aircraft carrier. We had 3 helicopters. We were fixing to go to Vietnam with those helicopters. And one of them had been used to pick up one of the Apollo astronauts. I believe it was the Apollo. It might have been the Gemini. I'm not sure. I need to look that up. But one of the ones that we were carrying with us and going to use in Vietnam had been used in the space exploration to pick up the astronauts when they splashed back to Earth. Thank you again. And we all look forward to our future in space exploration. And now I'm going to share my screen. And during this virtual field trip, students describe the physical properties, locations, and movements of the sun, planets, moons, meteors, asteroids, and comets. Understood that gravity is the force that governs the motion of our solar system, and describe the history and the future of space exploration. Ms. Ramirez talked about the suns, the planets, and the moon. Mr. Monroe covered meteors, asteroids, and comets. Ms. Nash about the force of gravity. And Ms. Fuller talked about space exploration. Thank you. How did we do, teachers? If you would, go to www.tiny.cc/EEC feedback and send us a quick little form back. It won't take you long, and we would appreciate it. And please have a great day and have a great future. Thank you again for joining us, and goodbye for today.